Okay, Assalamualaikum. So here is the example of isomorphism graph questions. So the question is, you are given four graphs P, Q, R, and S. Identify the two isomorphic graphs. It is basically means that they want us to find two identical graph or similar graph. Okay, so here, if you get this question, you gotta do 5 steps. Okay, first you gotta write the number of vertices and edges, and then vertices and its degree, and then degree sequence, bijective or not, and the preserved adjacency. Let's go one by one. So the first step is you have to find the number of vertices and edges for every graph, for each graph P, Q, R, and S. You just need to do this table, number of vertices and number of edges. So for example, the graph P, number of vertices is 5, 1, A, B, C, D, E, so it's 5. So we write here 5, and then we cannot just write the numbers of edges or numbers of vertices, but instead we must write the words to A, B, C, D, E. Okay, A, B, C, D, E in the curly braces. Okay, and then the same goes with the number of edges. You got to write the number of edges A, B, B, C, C, D, D, E, E, A. You total up, and then we got 7, and you must write the words too. Okay, and then that's all for step 1. What the conclusion for step 1 is, we got to eliminate the graph that has different number of vertices or edges. For example, in this example, you can see that the Q graph can be eliminated because number of vertices and number of edges of every graph is the same but Q, right? So you can eliminate this because our objective is to find the identical or similar graph, right? Isomorphic. Okay, so we can eliminate Q. Okay, so that's why at the step 2 we do not have the Q graph. So on the step 2, you have to find their vertices and its degree. Okay, so let's do for every graph but Q, because Q already eliminated. okay, right now the vertices for graph P is A, B, C, D, and then for the degree, you know, right, how to find their degree. So the degree of, for example, let's look at graph P. The degree of A consists of 2, 1 and 2. Degree of B consists of 1, 2, 3, 4. Okay, so A has 2 degree and B has 4 degree. So let's look at this. So we write here 2, 4, whatever the degree is lah. Same goes with the other graph, R and S. Okay, that's all for step 2. And then for step 3, we must find their degree sequence. We must write the degree sequence of each graph. Okay, the degree sequence is basically you copy je lah. You copy the degree here at previous step, but you must make it in sequence, like the name, degree sequence, right? So 2, 2, 3, 3, 4. 2, 2, 3, 3, 4. Okay, because at here it's 3, 4, 2, 3, 2. So it must be in sequence 2, 2, 3, 3, 4. Okay, and then the next step, we have to find if they are bijective or not. Okay, before I forgot, you actually have to write the conclusion for the degree sequence and for all the steps, which is, for example, to conclude, graph P, R and S have the same degree sequence. Okay, and then for the bijective, you can see here. Okay, bijective is means that the degree of elements from graph P equals to the degree of elements of S. Okay, for example, A has 2 degree, and then let's see if Q has 2 degree too. Okay, so at graph S, is Q has 2 degree? Yes, Q has 2 degree. Okay, so let's get back to where we left. Okay, so that's basically bijective. Every other elements in P has the match for every other elements of S. Okay, you got to do all graph lah, P, S and R. Okay, and then the conclusion, don't forget the conclusion. The conclusion is graph P, R and S are bijective. Okay, the last one is preserved adjacency. What is preserved adjacency? It's related to the neighboring concept lah. Okay, first, okay, let's look at graph P. We can see here A has 2 degree, B has 4 degree, and E have 3 degree. Let's look at the other graph. For example, we choose the point A. Okay, so point A have the neighbor 4 and 3 degree. So it's like this lah, 2, 4, 3, right? So we have to find the same shape, the same points as this graph P at another graph. Means that we have to search for points that have 2, the neighbor is 3 and 4. For 2, the neighbor is 4 and 3. Okay, so this is 2, this is 2, this is 4, this is 3, right? So let's look at another graph. For example, graph R. Okay, there has 2 points that have 2 degree. So for example, if I choose this point N, this point N has 2 degree, the neighbor has 4 degree, and the other neighbor has 3 degree. So it match. It may be isomorphic with the graph P, but we have to check for another degree, for another points too, not just N points. Okay, so we have to check each of the elements. Okay, so let's look at the graph S. Is the graph S have the same points like the graph P and R? So this is 2. Is it 4 here? Yes. Is it 3 here? Yes. So it's similar to P and R. But we can see here another point. Can we check? We can check another point. For example, we take the point B. B has 4 degree, and the neighbor has 2, the other neighbor has 2. Okay, so let's look which graph has 4, 2, 2. Okay, so this is 4, so 1, 2, 3, 4. Is it here is 2? No, this is 3. Okay, is it 2? Yes, it's true, but it doesn't meet the it doesn't match the graph P points, right? This is 4, 3, 2. It's supposed to have 4, 2, 2. Okay, so this is eliminated immediately. Okay, because this doesn't meet the isomorphic theory, what we call that, the isomorphic features lah, elements. Okay, the adjacency is not preserved. Okay, let's look at the graph S. Okay, this is 4 degree and the neighbor is 2 degree and the neighbor is 2 degree. Yay! So we have found the two isomorphic graphs, because graph P and graph S has identical, or the adjacency are preserved. So graph P and S are isomorphic. So we can write here that graph P and S are isomorphic. But before that, what is this, right? So basically you have to write the graph, and then in here you have to write their elements or edges from A to B, and then equals to edges from Q to R. Okay, they are equal, so we have to do this the arrow here kan. Edges B and C equals to Q and V in terms of their degree. Okay, that's all. So recap, we have 5 steps. First, find the number of vertices and edges with the number and also the alphabet. Okay, and then step 2, vertices and degree. Just now vertices and edges, but here vertices and degree. Just list down the vertices A, B, C, D, E. Okay, and then the degree you have to search at the graph. Okay, then number 3, degree sequence, just under the table of vertices and its degree. Okay, by sequence, just copy the degree of previous step. Okay, and then number 4, bijective or not bijective, is basically the degree of here equals to the degree of element here. Okay, then the last step is preserve adjacency. The edges here equals with the edges here. The neighboring is the same. We must check the neighboring for every edges lah. That's all.